Hey everyone, today's video is on trig functions of any angle, where we'll learn to evaluate trig functions of angles that can't be found on the unit circle. So the way we'll typically see these problems is they will give us a point that is graphed on the terminal side of an angle, and using the terminal side, the x-axis, and the vertical line to the x-axis, we can evaluate the sides of our right triangle using Pythagorean theorem. So the coordinate of this point is made up of the x and the y, the x being the horizontal distance that your point is from the origin, which would be this side of your right triangle. And the y coordinate would be the vertical distance of your point from the origin, or the vertical side of your right triangle. So as long as we make our right triangle with the x-axis and the vertical line to the x-axis, we're always going to have a right triangle that we know two of the three side lengths of just by knowing this coordinate. So you can never, ever, ever make your right triangle using the y-axis. This is not an acceptable right triangle for evaluating trig functions. So once we know that, then we can use Pythagorean theorem, or this is actually a derivation of the Pythagorean theorem, that solves for the hypotenuse of the triangle, which we're calling in this case r. So the one side of the right triangle squared plus the other side of the right triangle squared equals the hypotenuse squared. And then if we solve it for the hypotenuse by taking the square root of both sides, we end up with this formula right here. So once we know the two sides, we can find the third side, and once we know all three sides, we can generate any of our trig ratios. So sine, of course, is the opposite side over the hypotenuse. The opposite side is always going to be the vertical side, or the y-coordinate, and the hypotenuse is always going to be r. This is the same that we've seen SOHCAHTOA way back in geometry, and it's the same thing that we saw in the unit circle. The only difference was the unit circle, the hypotenuse was always 1. So we didn't have to express it because any fraction divided by 1 is simplified to the numerator. So the sine of the triangle would be the opposite, or the y side, over the hypotenuse, or r. Cosine then would be x over r, or the adjacent side over the hypotenuse. Tangent is opposite over adjacent, or the y over the x. Cotangent is the reciprocal of that, or x over y. Secant is the reciprocal of cosine. That's how we get the r over the x. And cosecant is the reciprocal of sine, or r over y. So really nothing new there. Okay. What we have to be careful of in this unit is that because our angle could be graphed in any quadrant, we need to make sure that we pay attention to what trig functions are positive in which quadrants. So we have a mnemonic called All Students Take Calculus to help us remember. All corresponds with all, students corresponds with sine, but we also need to remember that cosecant is paired with it as its reciprocal. Take corresponds to tangent and cotangent, and calculus is cosine and secant. So that's telling us which trig functions are positive in which quadrants, starting with quadrant 1, moving counterclockwise to quadrant 2, quadrant 3, and quadrant 4. The reason being for this is because of the signs of the x and y coordinates in each quadrant. In quadrant 1, everything's positive, the x's and the y's, so all of our trig functions are positive. In quadrant 2, the x's are negative, but the y's are positive, so anything that involves just a y coordinate is going to be positive. So if we remind ourselves, sine is made up of the y coordinate over the r, and cosecant, its reciprocal, is the same thing. And the y is positive in quadrant 2, so sine and cosecant are positive in quadrant 2. I should mention that the r value, when you find it, the hypotenuse, is always going to be positive regardless of what quadrant you're in, because you can't take the square root and end up with a negative answer. That's impossible. Okay, so the r value will always stay positive in all of these ratios. In quadrant 3, both the x and the y are negative, so the trig functions that involve both the x and the y are going to be positive because they will cancel each other out, which is why tangent and cotangent are positive in quadrant 3. And finally, in quadrant 4, the x's are positive, but the y's are negative. So anything just involving an x, and of course the r, like we said, is always positive, is going to be positive. And then anything involving a y coordinate, like sine, tangent, cotangent, and cosecant, those are all going to be negative. Okay, so come with any questions that you have, and we will talk about how we'll see this in a math problem.